Hello friends, Namaste and welcome to Ramesh Knowledge Index. Today we will be continuing our series of NTSE preparation and we will be looking into a very important topic from mental ability, that is number series. So I will give you some important series and then we will look into the details of it. We will excavate the topic. So without wasting much time, let us begin. Now look at the following series first and try to guess the pattern that is being followed. If you look into the first series, that is 1, 2, 3, 4, 5, 6, 7, 8, I don't think it's very tough to identify. These are natural numbers. Okay. Now if you look into the second column, it is 1, 4, 9, 16, 25, 36, 49, 64. Even that is not very tough. These are perfect squares of the numbers given in the left hand corner. If you look into 1, 8, 27, 64, 125, 216, 343 and 512, these are perfect cubes. Now the real story begins from here. So you have 2, 12, 36 and this is 80, okay, 150, 252, 252, 392 and 576. Can you guess what is the sequence that is being followed? Now it has something to do with the numbers which are written on the left hand side. I mean these numbers. Okay, so try to guess the pattern encompassing these three columns. Okay, so if you give a closer look, you will identify that the sequence that is being followed is n cube plus n square. So what is the sequence? N cube plus n square, and it's very evident. You see 1 plus 1 is 2 and it could be any other combination, but here you see 8 plus 4 is 12, 27 plus 9 is 36, 64 plus 16 is 80, 125 plus 25 is 150, 216 plus 36 is 252 and so on. So I just want to tell you that you must note these series because many a times in NTSE stage 2 directly series have been asked from these columns. Okay, so note them down and try to practice them every day. Then n cube minus n square, this series is n cube minus n square. You are subtracting n cube from n square, you get 0, 4, 18 as you can see. So try to repeat it. 0, 4, 18, 48, 100. See here the special number is 100 because you know it is 10 square as well as 5 cube minus 5 square. So that makes it easy. Like whenever you see 100, the two trials that you give is perfect square and then n cube minus n square. 180, 294, 448. Then n cube plus n. This series is n cube plus n. I think it will be clear with this. Okay, yeah, 2, 10, 30, 68, 130, 222, 350, 520. Okay, look into n square plus n. 2, 6, 12, 20, 30, 42, 56, 72. Okay, so note them down and I think whenever you will have n square plus or minus 1, n square n cube plus or minus 1, then it will be very easy for you to look into the pattern. But when it comes to these things, many a times we find them chaotic. We do not get the pattern that easily. So note them down and try to find more such patterns like n cube minus n, n square plus n. Okay, and then we will move on. I'll repeat it once again. N, there are natural numbers, then square numbers, then cube numbers. We have n cube plus n square, that is 2, 12, 36, 80, 150, 252, 392, 576. N cube minus n square, that is 0, 4, 18, 48, 100, 180, 294 and 448. N cube plus n, that is 2, 10, 30, 68, 130, 222, 350 and 520. Okay, n square plus n, that is 2, 6, 12, 20, 30, 42, 56, 72. If you see this, n square plus n can also be written as n into n plus 1. it can be written as n into n plus 1. Okay, so if that is so, you will see 1 into 2, 2 into 3, 3 into 4, 4 into 5, and this is a very famous series. Okay, so I think you get the idea. Okay, 2 is again a very special number wherein you have, wherever you see 2, you can find it near to the square of 1. Okay, so that is. Now let us look into some examples of number series so that it throws more light into the topic. So the first question is 2, 3, 5, 7, 11, 13 dash and 19. It's a very famous series, and I think you would have guessed it. This is the sequence of prime numbers. Prime numbers. Okay, so 2, 3, and what is the speciality of prime numbers? It is that you try to put them into any pattern and they don't follow, and that is the pattern that prime numbers have. So this is a very special series where there is one more example relating to it. We will look into it in the further section. 2, 3, 5, 7, 11, 13, then you would have 17. So this is 17. The answer to this question is 17. Okay, now the next one, 5, 7, 12, 19, 31, 50, and then what? Again, this is also a very famous series, and it is known as, give it a try before looking into the solution, Fibonacci. Okay, so in Fibonacci, what do we have? The preceding two numbers add to give the third number. Okay, so 7 plus 5 is 12, 12 plus 7 is 19, 19 plus 12 is 31, 31 plus 19 is 50. So you would have 31 plus 50 equal 81. So the answer to this question is 81. Okay, now let us look into the next series, and it is 3, 9, 24, 48, and then what? Now when I look into the question, something is revealing, but the fact is it hardly follows some pattern. The only thing that I can correlate this to are perfect squares. If you see, I think this must be 8. Yeah. So if you see, there's a small error, changed 9 into 8. Okay, so if you see, if you will try to find the sum difference, I don't think they follow some pattern. If they do, then let me know in the comment box. How I see this is near to a perfect square, that is 4. This is near to 9. This is near to 5 square, that is 25. This is near to 49. Everywhere you have subtracted 1. Okay, so minus 1, minus 1, minus 1, minus 1. Now what is the speciality of 4, 9, 25, 49, except for the fact that they are perfect squares? They are perfect squares of prime numbers. If you see, it is 2 square, comma 3 square, comma 5 square, comma 7 square. So the next one would be 11 square. So 11 square minus 1 is 120. So the answer to this question is 120. This is the answer. Next series. Okay, so the next series is 4, 6, 9, 13 and a half, and then what? Give it a try. So like, this is one of the most traditional approach wherein you multiply it to some numbers. Wherever there is fraction, you try multiplying or adding. If you add, I don't think you will find some pattern. But if you multiply these numbers with 3 by 2, and believe me, multiplication with fractions is favorite for NTSE stage 2. So if you multiply 4 with 3 by 2, you get 6. Then you multiply 6 with 3 by 2, you would get 9. Then you multiply 9 with 3 by 2, you would get 27 by 2. That is 13 and a half. and then you multiply this to 3 by 2, you would get 39 by 2 plus 3 by 4. That's something like 4. Try calculating this. 4. So if you see, it's 78 plus 3, 81 by 4, that is equal to 20.25. so it's 21 by 4, the final answer. 21 by 4. Okay, hope you enjoyed it. I would bring more questions on number series in the upcoming video. Till then, stay tuned, stay healthy, and stay safe.